Hello. Today I want to show you how to create an effect like this one, this liquid inside of the bottle where you can control the amount of liquid inside of the bottle, and also you can see that the liquid behave according to the bottle's rotation. So for instance, say that we have the bottle half full or half empty, we can rotate and the liquid will just rotate accordingly to that, you know. Yes. And also, like, we can try to do something else with this one. We could do some wobbly effects as well. um, so right, let's starting by deleting this shader, and as you can see it's just a mesh. And I want to explain what is my way of thinking for what's my approach for this kind of problem and how to solve it. Like, for example, to make the bottle disappear and appear, which is quite simple. Um, so basically, what I have in here is an UV coordinate. Uh, so like my way of thinking is, so say, so if you guys know how UVs work, so basically here we have X and Y positions, and at this top corner they're both zero because they're both black. There's no color in here, but when you're going down this vector here, for example, which is the Y axis, this is basically our GB stuff. So this will be green, our green channel. So in here, our green channel is totally green. So X will be 0 in here, and Y will be 1. And the same goes for this side. So X and Y here will be 1, and here will be 0. And over here, the both will be 1, X and Y. So my approach for this um, this effect, to make the bottle disappear, we're gonna work with the Y coordinate, right? Because we want to make the bottle appear from bottom. The bottle appear from bottom to up. So for that, we're gonna use this coordinate. So basically, we're gonna say that our UV dot Y is bigger than a variable here. We're gonna call it limit. If this is true, if if UV dot Y it's bigger than limit, we're gonna like colorize it. So we're gonna print a color. Otherwise, we will discard the pixels. So this variable here will be uniform, so we can control that. So for example, say our v dot y, say that our limit will be like, I don't know, over here. Let's put right in the middle, 0.5, right? So we're gonna check, is our uv dot y bigger than limit? So if our v dot y is bigger than limit, let me see. So if our v dot y is bigger than limit, we're gonna colorize everything. So in here, so 1, for example, 1 is bigger than 0.5. Yes, so we're gonna print, or we're gonna show these pixels. Otherwise, we're gonna discard everything over here. Or we could do it like the other way around as well, but for today, we're gonna do this way. So let's head back to Godot. So for that, we're gonna have to create a new shader. Let's create a new shader in here. New resource shader. Let's call it liquid. Yes. So well, for the start, we're gonna start simple. We have to work with something. So for that, we're gonna declare a variable in here. It's gonna be uniform. It's gonna be a vec tree. It's gonna be named color, and I'm gonna just put some color for us to understand what's going on. And in here in our albedo, we're gonna say that albedo will receive our color, right? So it's gonna be black probably because we're using source color, but we have to assign the material, the shader in here, black, and then now we can change the color of the bottle or the liquid inside of the bottle. Yes, so um, as we could see there, I said that it's an if statement. If our uv dot y is bigger, then let's declare another variable in here, uniform. It's going to be a float. Let's call it, I'm going to call it edge in here. If our uv dot y is bigger than our edge, we're gonna show some color. Otherwise, we will discard the pixels. All right. Apparently everything's working. So if I do this now, yep. We could do the other way around as well. So if you change this, probably it's gonna be the opposite way now. Yes. But for today, we will do this way. So this is like the first step. Right now, well, we can see it's there's no other is not rendered the part inside of the mesh, so we can change the render mode. Let's say it's let's call it let's disable the cool. So now you can see that. Also, we have a problem here actually, right? Because like this is hollow, and we can see inside. There are like multiple ways of solving this thing. We could use like sign distant functions and then like see project an array from the camera and then like draw a mesh in here. But like today I'm gonna do a simple thing, which is let me explain. Let me go back in here. So we know like we have normals, right? So basically a mesh would have a normal pointing this direction. So in that case, like our cylinder is like this, right? So we gonna grab the normals of this portion here, and we're gonna make it point up, and then that will give us a pseudo lid. It's something to fake a lid in here. So for that, we have to declare another variable, which will be the uniform vec3 will be, I'm gonna call it the normal there, which stands for directions, and gonna be also a vec3. So red, green, and blue. Yes, red, green, and blue. Oops, my bad. Let's say 0, and let's grab the y-axis, and let's say the y-axis will be 1. So in here we could do something like we can say that if the vertex, if like it's not facing the camera, we're gonna make the normals go up. So for that we can create another condition here. So we have this variable in here, front facing, which basically means that we are facing something. You see it's already changed, but we're gonna like say if it's not facing the camera, we gonna grab the normals and we gonna pass it our normal direction. Like this. Yeah, so it's already 1 in there, so you can see. Let me do it here. Oops. Let me see here. Okay, if it's 0 now, it's like this, but if it's 1, kind of looks like a lid, but it's not. It's just our normals are twisted in a way that it make it looks like there's something, there's some geometry in there, but there's nothing. And also we can say that if not on normals will just be we're gonna clamp this. Well, we could like do something like clamping or normalize this vector, and we could do the same in here. Normalize. We're gonna just normalize this vector as well, but we don't need to do that actually. Just to force something to happen here. Right now it looks pretty decent, but there's like a problem in here. We are using basically a lot of unnecessary math or unnecessary like if statements or branches. And for shaders, this is not good at all. We have to avoid this kind of things here, right? So let's exclude everything because this doesn't feel right. We could make it 10 times better. So for that, we could do something way more simple than that. So there are some mathematical functions that we can use. One of them is the step function. So basically the step function, well, let me declare it here and then I can talk about that. So let's do a mask. And then let's say the step function. So basically the step function receives like 2 values. So this way this works is like, let's call it A and B. So it will return 1 if A is smaller or equal B, otherwise will be 0. So it's basically the same thing that we were doing before, but in a more smart way. So what we can do with this is we could do something with this, right? We could say that our uv dot y, we could say uv dot y. Yes, uv dot y. Oops. And we could also use what we were using before, which is our edge, right? So it's literally doing the same thing that we were doing before, but just with a step function. And to see the results, we could plug this in. Oh, sorry about that. Plug this in the alpha channel, and then let's see what it does. So what we have now, we have the same parameter in here, and then we can use it the same way as we did before, but look, without those if statements. You can see it's there are some artifacts in here. It's a bit weird, but we can solve that with the depth prepass alpha, which is gonna make it better. Yeah, see, we have the same results as we did before, but as you can see, we are missing the lid. So for the lid, we could do something similar that we did with the step function, but we could use a different function for that. So for the lid, we could do something like we could use a thing called mix, which is also a constant or a function. As you can see, it's a function here. So for that, we could do something like we can take our normal. We basically what we need is like our normal from what we have right now, and our normal with the up direction, and also we need that constant front facing. So we could do the same thing. So let's grab the normal direction. Let's say the normal direction, and our normal, and we could use the front facing as the factor in this function. As you can see, it's an error, invalid arguments for the butane and function mix, so we cannot use a bool, so we're gonna have to convert it to float. Yes, right, and now we have it. It's basically doing the same thing, but as you can see, still hollow is just an effect, pseudo lid in here. We could also make it two colors, so the effect is more prominent. So for that, as you already can think, we could use the same thing as we did in here. So let me declare a different color. Let me call it color back, and this will be color front. So let's say in here our albedo will receive mix, and let me just drop these values in here. Oops. Color front and color back, and let's copy it too. Yeah, all right, let's see how it looks now. So color front is this one. So we see it's inverted. I'm changing the color front and it's changing the lid, so for that we can do the same thing as we did before. I reckon we'll be good, or we can like do the right thing for a matter of organizations. So let's just keep the things a little bit more organized. We could do that like this. Yes, all right. So right now we move, but you see like the shader we don't have the cut that we want when the bottle is like this. We want the liquid to have a cut right here, you know. So for that, we could use some other variables. We're gonna have to use the vertex instead of using the fragment, and also we're gonna be it's good that if we could pass some values from the vertex shader to the fragment shader. So for that we can use a thing called varying, and I'm gonna declare a new variable here called position. Yes. All right, and let's start to work in the vertex part of our shader. So what we want is we want to get the vertex and change it to the world space, right? So for that we could declare a variable in here called vertex world, and the way we can do that, we can use a thing called a model matrix. So like if you guys are a little confused about what it does, Godot has like a good documentation, which has like a lot of self-explanatory things in there. Let me see if I can find it here. So yeah, this is the Godot documentation, and then you can read in here model matrix. So the description is local space to word space transform. Word space is the coordinates you normally use in the editor. Yeah, so for that we could do something like a model matrix multiplied by our is a vec4 vertex, and we can do some swizzling here, x, y, and z, x, y, and z. We could invert, well, anyway, let's keep it like that for now. And what we can do, well, right now let's just use this position, and let's say, for matter of organizing things, let's put it in here. Yeah. So what we can do with this right now, right? So right now we're using the uv.y, but we could do something like this now, because you're getting this and word position, and you can see it's it's up the opposite way. So we can change for this thing now. Okay, let's see if it's working. So when I move it now, and I move the bottle, yeah, it does like this. Or yeah, this is good. It's looking good, right? So like what we want to do now is we want to have this wobbly effect, right? So for that we could do something also using the position, but for that we can do, let's work in here, a variable called wave. It's gonna be float, and we're gonna use a mathematical function called sin, and for that we can use the position. Now, so basically I'm using this variant here, so now I can access in here like I did here too, so we can do the same thing. I can say that position dot y will be multiplied by 5 plus time, plus a variable time. Let's see what it does. Apparently nothing. So for that, now we can have more control over this thing. It does nothing because I'm not assigning this value to anywhere, in any place, you know. So I could do something different. I could, for example, have I could take this thing and use it here now, and then something will happen, you know. But this is not what we want. So let's keep it like that right for now. But what we want is like we want to have at least like 2 variables to have some sort of control. So for that, we're gonna declare them in here. They're gonna be uniform float, and let's call it the first one. Let's call the wobble underscore amount, and well, let's keep like this for now. And also we want to control the how fast it moves, so let's copy this and call it speed. Yeah. So let's go down here. So for the amount, it's quite simple. We can just multiply our amount in here. Also, what we can do is, well, for like a better visualization, let's I'm gonna declare another variable here. Let's say liquid. Let's say it's wave plus our edge, and then I can just plug this in here, I guess. Yep. Wobble amount. Okay. Yes, now we can see something. We, of course, we don't want this to go so far, so we could do something in here, like to define a range for that. So will be this and this gonna be 0.1. So it goes from 0 to 1. It's all the way to 1, but we don't want that. Alright, now we have something a little bit better. And for this speed, we could multiply this thing, time, and the wobble speed would be in here. We could do the same thing, but let's just do it in here right now. Let me see, something's a bit off. Let me try to understand what's going on, because it looks a bit off to me. Oh yeah, I know why it's a bit off. It's because we are using the position Y, so then we don't want this to happen. We want to go in this axis, which is the axis. So I think, yeah, like that. Oh, much better. So yeah, now we have this motion and we have this control. Yep. So for the speed, we can increase as much as we want. So let's say over here, and let's put it to 0.02. It's very little. 0.5. Nope, sorry, 0.05. 2s. Wobble amount. Yep. Let's do it like this. So it's gonna be a little better for our control. Yep. All right. Yes. So this is what I have now. So when we rotate it, it's gonna do like this. Yep. So let's put this in the side of the bottle. It's already the bottle's child. Let's do this, and now when you move it, yep, you can see some. There are some artifacts, but this is just because of the texture. But you could fix that easily. But the most important thing is this for us. Oh, sorry. So now we have this effect in here. We could do this and this, and also we can control the edge and the color. Yeah, I think that's it. Yeah, thanks for watching.